Hello students, welcome to aimsindia online classes. This is the chemistry session. Here we are discussing about the chapter periodic classification. In this session we are going to say about the earlier attempts for classification of elements. That means nowadays we are following modern periodic table. Often you might have observed this modern periodic table in your classrooms or laboratories, isn't it? But actually that is not the first classification. Before that, so many classifications were given by scientists, but they were failed because of some defects or drawbacks in those classifications. But those classifications are very important. Even though they are failed, they are very important because they have laid a correct path for this present classification. So we need to know those classifications also compulsory. Now let us see in this session about those earlier attempts for the classification of elements, who tried and in which way they have tried to classify these elements. Okay, now let us start this. First of all, what is the necessity for the classification of elements? Let us know. Is it needed to classify the elements first of all? Yes, it is. In the beginning of 18th century, only few elements were known and hence it was easy to remember the properties of those elements individually. Yes, at the starting of the 18th century, they came to know very few elements. So as there are very few elements, we can remember, it will be easy to remember the properties of each and every element separately and individually. But by the discovery of new elements, which is presently about 118 elements, it is very difficult to remember their properties individually, isn't it? If there are only 5 or 6 or 10 elements, we can hardly remember their all individual and separate properties based upon the elements. But if there are so many elements, how many are there nowadays? Around 118 elements they have discovered so far. So the remembrance of the properties of these all 118 elements individually is a difficult task, isn't it? Thus, it was felt the need of some simple method to simplify and systemize the study of properties of various elements and their compounds. So, they have thought then, as the number of elements increased, so they thought that it is better to segregate these elements based upon certain properties into different batches so that we can understand and remember the properties easily batch wise. So this necessity led to the classification of various elements into different groups or batches based upon certain properties. So the following are the advantages of classification of elements. So by the classification, we can get these advantages. What are those? To study the elements in a systematic manner. So we can understand the properties of the elements in certain systematic manner. And we can correlate the properties of the elements. Yes, based upon the groups, the elements which are classified into particular group or batch will be considered to have same kind of properties. So if we know the properties of an element in a group or batch, we can consider the same properties for the remaining elements also. In this way, it is made to remember the properties of the elements by segregating them into groups. And it is made to know the type of different compounds that different elements can form. Yes, this classification of elements into batches also made easy to know the type of chemical compounds formed by certain elements. So the elements which are there in a particular classification or in a batch, all they will form almost same kind of compounds. So if we know about one element, the same can be accepted with the remaining elements in that batch. In that way, it is made easy here. So earlier attempts for the classification. Now, the other advantages we have seen. Now, how they have tried in the earlier days for the classification of these elements. Let us see here. Earlier, many attempts were made to classify the elements for better understanding. Now, let us see some important attempts among those. Okay. First among those is Lavoisier's classification into metals and non-metals. Of course, before that, we might have heard this classification of these all chemical substances into four elements. Those we call as Panchabhutas. It was considered all the substances in this matter are made up of these Panchabhutas. What are the Panchabhutas means? I think you know those. So in that way, they are classified into this book. But chemically, the classification was started with Antony Lavoisier. He classified elements into metals and non-metals. So by the late 1860s, Antony Lavoisier classified the elements based on the similar physical and chemical properties into metals and non-metals. Okay, he was the first scientist who tried to classify the elements based upon the chemical nature and physical properties of the elements. So based upon the physical properties, he classified all the available elements into two groups or two batches. Those are metals and non-metals. So what are metals? An element which has the properties like lustrous, good conductor of heat and electricity, ductile, malleable, and solids at room temperature, and has tendency to lose one or more electrons is classified as metal. So based upon these physical properties, he classified certain elements as metals. What are those physical properties? They luster, means they have shining property. They are good conductors of heat and electricity, and they are ductile. Ductile means they are they can be made into thin wires. They can be drawn into thin wire. That property is called ductile property. Malleable. So those elements can be beaten into thin sheets. This property is called malleability. And mostly these elements are solids at room temperature. And these elements are having tendency to lose one or more electrons. So those elements which are having these all properties he classified as metals. See, some examples for the metals are shown here. Okay. Next, non-metals. An element which has the properties like quite opposite to metals properties, we can say simply like no luster, bad conductors of heat and electricity, non-ductile, non-malleable, and have tendency to gain one or more electrons are classified as non-metals. So the elements which are having properties in quite opposite to that of metals are classified as non-metals. Means they don't have luster, means they don't shine, they cannot conduct electricity or heat through them. That means bad conductors of heat and electricity, and they cannot be drawn into thin wires. That is non-ductile. They cannot be beaten into thin sheets. That is non-malleable, and they have the tendency to gain one or more electrons. So the elements which are having these properties are classified into non-metals. So some examples for the non-metals here: silicon, antimony, sulfur, carbon, nitrogen, oxygen. These all come under non-metals which are having these properties. Okay. In this way, he classified all the available elements into two batches. They are metals and non-metals. Reason for rejection of this classification. Actually, as we told, it is the first classification based upon the physical properties of the substance, chemical substances. Even though he tried to classify, but this classification was rejected. Let us see here what reasons are responsible for the rejection of this classification. One, it is the elements were divided only into two groups, which does not help much in the study of the elements. For example, all the metals are kept in the same group. Only two groups are there. One, it is metals, other one is non-metals. So all the metals are classified into same group. But among the metals again, there are different kinds of metals. Means some are highly reactive metals are there, whereas some are least reactive metals are there. But all these metals are classified into the same batch, that is metals group. So that is somewhat inconvenient to recognize the properties of the elements. And next, all the non-metals are classified into same batch, isn't it? Because there are two batches only. But out of these all non-metals, some non-metals are having high reactivity, whereas some non-metals are having the low reactivity. So there are some differences in their chemical properties, but all the non-metals are categorized into only one group. So they are the limitations. This is one limitation we can say. Next, there are some elements which have properties of metals and as well as non-metals. Such elements are known as metalloids. So Lavoisier classified all the available elements into only two batches, but there are one more kind of elements which can show the properties of both these metals and non-metals. So for this, no classification was there in the Lavoisier's classification. So it is also we can say as one limitation. Those elements which are exhibiting the properties of both metals and non-metals are called as metalloids. See some examples for the metalloids are shown here, like boron, silicon, germanium, arsenic, strontium, antimony, tellurium, polonium. These all are elements which can exhibit the properties of both metals and non-metals. So these are called as metalloids. So there is no separate classification for these elements by the Lavoisier. So this Lavoisier's classification is rejected because of these drawbacks. Okay, next. One more scientist next classified was Dobereiner. In 1817, Dobereiner classified the elements into groups of three elements, such that the three elements had similar properties, and atomic mass of the middle element was the arithmetic mean of the atomic mass of the first and third elements. So the group of such three elements were called as Dobereiner's triads. Okay, the next scientist was Dobreiner. He classified three elements into one batch, and he arranged these three elements in the increasing order of their atomic mass. Then he observed one more interesting point in common among these set of three elements. That is, the atomic mass of the middle element is being nearly equal to, or sometimes exactly equal to, the arithmetic mean of the atomic mass of the first and third elements. So in that way, he arranged three elements as one set. He called his group of three elements as a triad. It is called in the honor of his name as Dobernier's triad. Okay, for example, if you see, he classified lithium, sodium, and potassium as one set. He called this as one Dobernier triad. In this set of three elements, the atomic mass of middle element sodium is equal to the atomic mean of the arithmetic mean of the atomic masses of the first and third element, that is lithium and potassium. If you observe the arithmetic mean of the atomic mass of lithium and potassium, that is 9 plus 39 divided by 2, it gives exactly 23. That is atomic mass of the middle element sodium. Okay, in this way he arranged three elements as one set, and he observed for these three elements chemical properties are being same, and at the same time he observed the atomic mass of the middle element is nearly or equal to the arithmetic mean of the atomic mass of the first and third elements. He called these three elements as one set, and he called those as triad. Okay, let us see some more examples for these Dovernier's triads. One it is chlorine, bromine, iodine. Here also, if we take the arithmetic mean of the atomic mass of chlorine and iodine, we will get a value which is near to the atomic mass of the bromine. Okay, next set calcium, strontium, barium. One more triad, sulfur, selenium, tellurium. In this way, he classified the elements into set of three elements called triads. But there are some disadvantages with this Dovernier's triad. What are those? The main drawback of this classification was that the concept was not applicable to all the known elements, but only to a limited number of elements. Hence, the law is rejected mainly. Okay, so actually, he tried to classify the elements into set of three, which are having similar chemical properties, and he arranged them in increasing order of their atomic masses. He arranged in this way some elements only. He was not able to arrange all the available elements at that time into these triads. Only few elements he was able to classify like this. That's the main reason it is rejected. Okay. However, one point became clear here. That is, the properties of the elements have some relationship with their atomic masses. So, by this classification of Dauvergne, the people they came to know some relation between the elements. That is, they have some relationship among the elements with their atomic masses. So that point became clear by this Daubernier's classification. Even though it is failed, it has given that clarity. Okay. Next, scientists they have tried to study the elements based upon this relation. Newland's law of octaves. So next classification was done by Newland. John Newland, an English scientist, in 1866 arranged about 56 elements known at the time in order to increase the increasing order of atomic masses. According to Newland's law of octaves, when elements are arranged in the increasing order of their atomic masses, there is a repetition of the properties of every eighth element as compared to the given element. So what he done? He arranged all the available elements at the time in the increasing order of their atomic masses. Then after arranging like this, he observed that the atomic properties, the properties of an element are resembling the consecutive eighth element to it. Okay. In that way, he arranged these eight elements as one set and he called those as one octave. So these are seven, there are seven musical notes according to Indian system. These musical notes are, as we know, sa, re, ga, ma, pa, da, ni. In the musical notes, there is a repetition of the same note after a gap of seven, isn't it? After the gap of seven, we get the eighth element again, eighth note again, which is similar to the first note. In the same way, among the elements also, there is similarity between the first and the consecutive eighth element when they are written in the increasing order of their atomic masses. It was found by Newland. So, by coincidence, Newland found the same pattern in the arrangement of the elements also. So, these elements placed in the same vertical row and also as a group, called as a group, have common properties. The elements, for example, the elements beryllium, magnesium, and calcium are grouped on similar basis and they resemble in their characteristics or properties. So, when elements are written in the increasing order of their atomic numbers, he observed the properties of an element are being resembling with the consecutive eighth element to that. For beryllium, the properties are being similar with the magnesium. So the elements like this, which are getting similarity in these properties, he kept down one to another and he called those as one column or one group. Okay. Now in this way, on arranging, beryllium, magnesium, calcium have come into one group, and these are having similar chemical properties too. But in this also again drawbacks. So here we have to remember one point. While he was giving this classification into octaves, they didn't come to know about the noble gases. Noble gases were not discovered so far then. So he arranged all the available elements at the time in the increasing order of their atomic masses. For example, first he has written hydrogen, then lithium, because noble gases were not known at the time. Lithium, beryllium, next boron, carbon, nitrogen, oxygen, fluorine, neon. Next, neon is not for known at the time. So after fluorine, sodium, magnesium, then aluminium, and so on. Suppose now if you take any one of these elements, suppose if you consider lithium, for this the consecutive eighth element if you find, what will be 1, 2, 3, 4, 5, 6. If you count from here, for this the consecutive eighth element if you count 1, 2, 3, 4, 5, 6, 7, 8. So for the lithium, the consecutive eighth element is sodium, and he observed these two elements are having similar chemical properties. So he kept this element sodium down to lithium. Now these elements he called as one group elements, and these elements exhibit same characteristics. In that way, the set of eight elements were called as octave by Lavoisier. Newland. Okay, if you consider from beryllium, for the beryllium, the consecutive eighth element will be magnesium. These two elements are having similar properties. And from magnesium, if we count the consecutive eighth element will be calcium. So in that way, these three, magnesium, calcium and beryllium are having similar chemical properties. So he kept these three elements as one group. Okay. So in this way, he classified elements into octaves. But in this also, some limitations are there. Let us see what are those disadvantages. One is this law could be best applied only up to the element calcium. So he tried to classify the elements around 60, but the octaves classification is only applicable till some elements only, the two till calcium, but it is not exactly suitable for the higher elements. That's a major drawback in this classification. So newly discovered elements could not fit into the octave structure. One more major drawback in this is discovery of noble gases. Actually, before discovery of noble gases, he classified the elements into octaves. Suppose if you say after helium, after hydrogen should come helium here. Or if you say hydrogen in these octaves, the consecutive eighth element for hydrogen will be fluorine, isn't it? If you count from here, 1, 2, 3, 4, 5, 6, 7, 8. So fluorine and hydrogen are having some similar properties. And if you see for lithium, sodium is a consecutive eighth element, so these two are having similar properties. He called them octave. But after the discovery of noble gases, here it should be inserted helium according to their increasing order of atomic masses. And in between, sodium, fluorine and sodium should be kept neon. When neon is kept here, now for the lithium, the consecutive eighth element will be, see what will be now, 1, 2, 3, 4, 5, 6, 7, 8. Neon is a consecutive eighth element for lithium. But lithium and neon are having different chemical properties, isn't it? In that way, after the discovery of noble gases, this Newland's octaves theory is failed completely. Okay, he could not fit these noble gases into these octaves, in this octave structure. In that way, this Newland's classification is failed, we can say. One more point, he failed to exhibit this feature with the higher elements. As I told in the first point, this theory or this classification is applicable only for the lower elements, the two till the 20 elements. Till calcium it is completely suitable. It is fit for those. But it is not suitable for the higher elements. Higher elements are not fitting exactly into these octaves properties. Okay, in that way, it is failed. Next classification is done by Mendeleev. Okay, Dmitry Mendeleev. So now this was the most successful attempt than the remaining all earlier. All the earlier attempts at okay at the classification of elements. So Mendeleev mostly successful. He succeeded in classification of elements, whereas the earlier classifications which were done by Lavoisier, Dauvergne, Newland, they have mostly certain limitations and failed. But Mendeleev was the most successful who done an attempt for the classification of elements. In fact, Dmitry Mendeleev is known as father of periodic table. Periodic table. Yes, the first periodic table was proposed by Mendeleev. The scientists before him they have tried to classify the elements, but they did not give the periodic table. They have tried to classify the elements in somehow manner, and they have given different batches, but they were not able to classify the elements into periodic table. But the first periodic table was given by Mendeleev. That is why we say father of periodic table is Dmitry Mendeleev. Okay, he had noticed a relation between the atomic mass of the elements and their physical and chemical properties. Yes, he also observed the same point. That is, some relation between the atomic mass and the chemical and physical properties of the elements. So he studied these properties and he tried to classify the elements based upon these properties. He observed that there was a periodic reoccurrence of elements with similar properties. So he arranged all the elements in the increasing order of their atomic masses, and then the elements which are getting the similar chemical properties he wrote one down to another. That means he continued writing all the available elements in the increasing order of their atomic masses. Then one element is getting the similar properties with the starting element, so he wrote down to that first element again. He continued writing again. In this way, the periodic table was designed by him. So Mendeleev started that uh, periodic table. So and then he has given statement that what he observed, that we call as periodic law. You can say Mendeleev's periodic law. He stated in that the properties of the elements are periodic functions of their atomic masses. So the physical and chemical properties of the elements are periodic functions of their atomic masses. That means the meaning of this is when elements are written in the increasing order of their atomic masses, there is certain repetition in the properties of the elements. So based upon this, he tried to classify the elements into groups, and hence he had drawn a periodic table by using this. Okay. One of the most successful aspect of this Mendeleev's periodic table was that he was able to predict the unknown elements more or less accurately. Yes, it is one of the important prediction where he succeeded completely. He predicted some unknown elements while arranging the elements into periodic table. He left some gaps in this periodic table, as there's some element to be found and it is to be filled by that gap. In that way he left some gaps by assuming the unknown elements which were not discovered yet. So those elements, as he expected, later they were discovered and they filled those gaps. He named those unknown elements based upon the properties where it is to be fit. So, based upon the column or based upon the elements present in that group, he expected the properties of those elements also. So, based upon the properties, he named those unknown elements also. As he expected, those elements were found later and they hang the almost same properties as he expected. For example, he expected an element down to boron in his periodic table and he named that element as Eka boron. Later, as he expected, that element was known and it is named later as scandium, which is having some properties similar to boron. And one more element he expected down to aluminium and he named that element as ecosilicon. That element also found later and it was named as gallium. And one more element, one more place he left for the element and he named that as ecosilicon. As he expected, that element was found and its name is given as germanium. So, in this way, he is mostly succeeded by leaving certain gaps for the elements which were to be found later. Okay, that is one of the most important successful aspect in the Mendeleev's periodic table. Mendeleev's periodic table simplified the study of elements. So, and when elements are classified into a table, the study of elements made easy here. It became useful in studying and remembering the properties of a large number of elements in a simple way. So, as he made these all elements into to arrange in a table, so the elements present in one column are considered to be one group. Now, the properties of these all elements will be similar. In that way, it is made easy to remember the properties of almost all the elements. These are the most successful points in the Mendeleev's periodic table. One more we can say, he was the first scientist who could classify all the available elements at that time. Almost 63 elements were known at the time while he was tried to classify. All the elements he tried to classify and arranged in his periodic table. That's the most successful point we can say in this. Okay. So now let us see the arrangement which was done by Mendeleev. Okay, this is a Mendeleev's classification. Okay, Mendeleev's periodic table it is called. So in this periodic table, the vertical columns, these are called groups. This we can say as one group. And the horizontal rows, suppose if it is in a horizontal row, so these horizontal rows are called periods, and these vertical columns are called groups. Vertical columns are called groups, horizontal rows are called periods. This is Mendeleev's periodic table. Despite its success, there were still a few shortfalls in the Mendeleev's periodic table also. Yes, even though it is more successful than the earlier, there are some drawbacks or shortfalls in this also. Let us see what are those. One among them is, firstly, he failed to place the hydrogen correctly on his table, because a hydrogen exhibits the properties of both alkali metals as well as those of halogens. So he confused there where to keep this hydrogen in the periodic table, whether along with the alkali metals or along with the halogens. That means alkali metals means highly reactive metals like lithium, sodium, potassium, rubidium, cesium, and francium. So it shows some properties similar to these elements. So he might have thought to keep these along with these elements in the first column. And at the same time, some properties of hydrogen are being similar with that of seventh column. That means halogens, namely fluorine, chlorine, bromine, iodine. So these elements properties are also being similar some with hydrogen. So he was in confusion that whether to keep this hydrogen in the these alkali metals column or in the halogens column. So there he kept two places for hydrogen, that we can say. So to assign it one position was difficult to made difficult to him. Okay, that is one drawback you can say. Also, isotopes of elements were proving to be a problem. Yes, after the discovery of isotopes, fitting these isotopes into the periodic table also became a problem to him. Because what does it mean by isotopes? The elements which are having same atomic number but different mass numbers are called as isotopes. For example, if you say hydrogen itself or carbon, let us take, we know carbon has three isotopes: carbon 12, carbon 13, and carbon 14. So as there are three mass numbers, they should be given three places for carbon in the periodic table based upon the masses. But he could only provide one place for carbon. So in this way, it became problem in setting these isotopes into the periodic table. This we can say one of the limitation. They could occupy multiple positions on the periodic table since their atomic masses are being different, but he could give only one position for element as their properties are almost the same. Okay, this we can say as one limitation. Instead of above limitation, Mendeleev's periodic table was the best classification of elements and proved a milestone in the field of chemistry. Of course, this is correct. Even though there are limitations in this Mendeleev's periodic table, even though it is kept failed, even though we are not following this now, but it is one of the most successful classifications because it laid correct paths for the classification of modern theory. The modern periodic table is classified based upon the paths laid by this Mendeleev's table. He given some conclusion that there is certain relation between the atomic mass of the elements and their properties. And he tried to arrange these all elements in the periodic table. So these are the most successful points from the Mendeleev's periodic table, even though it is failed. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos.